Now it seems like it's recording. All right. So we're going to do scatter plots and correlation. Maybe if I can find my mouse. There it is. Okay. Okay. So the first section is going to be scatter plots and correlation and just like how those things are related. Then we're going to go into regression. So yesterday we made those lines. That line would have been a line of regression. Okay.
So after this, will we do our final project?
Mm-hmm. Yeah. And I'll hand you all that stuff and kind of give you like your choices and whatnot.
Can you use the thing that I did from Talk
I'd rather not. No, you can't. No, because we really like then only did like more basic stuff, and I'm gonna have you guys do like a couple hypothesis tests and stuff like that on it. I know, just to make you suffer. Okay. So our objectives here are going to be to draw a scatter plot for all our ordered pairs. That's probably, no, I guess you could take a picture, but no, you don't, you shouldn't need to. Compute the correlation coefficient, which is, we didn't find that yesterday. Test the hypothesis is going to be that kind of difference between what we've always done before when we do these things. So what we always do, I don't have any idea what that symbol is called.
I was going to ask if that was like a G or like a backwards Q or a G.
I'm going to see if it... Holy crap, does it have it in here at all? Where are you? It's supposed to be a row.
A row?
A row, which just looks like a P without a. So this is what it looks like it's supposed to be. So like normally like a P has that thing, so it's kind of not a P-ish. I don't know why it has the weird squiggle tail. I've never seen one with a squiggle tail.
Wait a minute, what does that P have that the other P doesn't?
Not the, this P should have a, that's how you should draw a P. This is how you draw a row.
Well,
Do you draw your P's wrong?
P's like that thing?
Oh, well that's not how, you failed kindergarten, didn't you? So, yep, then we're going to do the equation of the regression line, which we did find that the other day or yesterday. Compute the coefficient, we didn't do that. Compute the standard error of the estimate, we didn't do that. Find a prediction interval, so remember like those mu is between, we'll have rho is between kind of things. Familiar with the concept of multiple regression. We're not going to do like the whole section on multiple regression though. Okay, so now I have to figure out.
Is that like 10-4?
Yeah.
Okay, so we're not doing all of 10-4 then?
Nope. Okay,
I
whoops.
thought I have a random P.
Yep. Okay, in addition to hypothesis testing and confidence intervals, inferential statistics involves determining whether a relationship between two or more numerical quantitative variable exists. So two or more, that just means like that I have that XY pair that we can kind of see on that graph, whereas a lot of the other stuff we've just been dealing with one interval. Correlation is a statistical method used to determine whether a linear relationship between variables exists. Regression is a statistical method used to describe the nature of the relationship between variables. That is negative, positive or negative, linear, nonlinear. There is also, we can actually, like your calculators can do different regressions. We're only going to worry about those linear ones. But like if your dots maybe kind of follow this kind of pattern, I could put a parabola on there. So your calculator can do a lot more things. We're not going to worry about that. Oh yeah?
Yeah. Probably didn't get it
What
right.
kind of? So like there's
It was
like
something about
like linear. So that one would have like
no,
a.
it was just about parabolas. That's
Oh,
what it was
oh.
about. It was asking about parabolas, and I was like,
Yeah, you
I
said
think
that.
It's like, what was the equation, or what is the equation for this parabola, or something like that.
Those can be rough to find sometimes. Okay, for this whole chapter, we're going to answer these questions. Okay, are two or more variables related? If so, what is the strength of that relationship? So that's that correlation. What is the type of relationship, linear or not linear? Let's see what kind of things they're going to have. Mostly, I think you're just doing the linear parts, but your calculator is really powerful and it can do lots more. Okay, what kind of predictions can be made? That's the hypothesis testing. Sorry, I'll go back. Okay, so those are the questions we're going to try to answer for these things. And usually, so we're going to let the calculator do most of those regressions for us. Did you have that already? Or am I ahead of myself? Okay, yeah, you're just drawing random stuff. That's nice. Okay. Are two or more variables related? If so, what is the strength of that relationship? Okay, so what that's going to look like, that's going to be our correlation coefficient, which is a numerical measure to determine whether two or more variables are related to determine the strength of the relationship between or among the variables. You don't have to write down all of that thing. Yep.
Did we talk about that yesterday?
Not yesterday, not really.
I don't know where I heard that from. Maybe last year, or freshman year, I don't know.
Yeah. Yeah, I mean, like, you should have been doing correlation coefficients every once in a while. Just randomly kind of spaced throughout your mathiness. Okay. What type of relationship is it that exists? Simple and multiple, so we're not doing that multiple piece. In a simple relationship, there are two things that we worry about, independent and dependent. So usually we'll have like time and something else. Time and distance. So the distance would depend on the time. Time is usually the independent variable because time is going to do whatever it's going to do no matter what. Okay. Multiple relationships, there are two or more. I didn't mean to click it. I was just trying to like highlight it. There are two or more used to predict a dependent variable, so maybe time and temperature relate to something else. Okay? So, and those are most like sciencey things are going to be multiple relationships. Okay? What kind of predictions can be made? So predictions are made in, the stronger the relationship, the more likely something is going to happen. My clicker is just not where I want it. Okay, so now we're going to start with just doing scatter plots. All right, you guys know how to make scatter plots?
Yeah.
Okay, and we've done scatter plots for like ever. So it should be pretty nice. And I need to make sure I'm clicking on both thingies. For a little bit. We won't do tons. Like, we'll let the calculator do most of it with us because we've already like known how to do most of these things. So we're just going to let the calculator do it. Okay, so construct a scatter plot. So I will, I'll kind of walk you through how we're going to do this on the thing. So hopefully you can see this on this video thingy. So let me get my calculator dude up here where you can kind of see it. Do you see it? Yep. Now let me find my mouse again. Whoops. Okay, so what that's going to look like is, I wonder what that's going to look like. That is not at all what I wanted to have happen. Okay, now I have to find it again. Is it back up? Okay, so I'm going to go to my stat list. Mouse, come on, mouse. Okay, so make sure your stuff's on. So stat, edit, list. So make one of the things in L1, one of the things in L2. Generally, you're going to make usually they have it set up pretty nicely in that this is going to be your X's, this is going to be your Y's. So do the cars depend on the revenue or does the revenue depend on the cars? So revenue needs to be my Y, which if you do it just in L2, it will automatically do that in your calculator. So I have 63, 29. I think it's selling cars, car rentals. There you go. So, okay, 20.8. This is going to take me forever. I wonder if these things are going to work that I can. No, why is that not going to work? That's weird. Oh yeah, I forgot that I was having problems with that. I haven't used it in a long time. All right, this is going to take forever. 19.1, 13.4. Yeah, or you can just use one of these if you wanted to right now. Okay.
Because then I need to make sure my scatter thing is on.
Yep. So 7, 3.9, 2.1, 2.8, 1.4, 1.5. One of the main things to do after you push enter, make sure that they match up, that you have the same number, because otherwise you missed one or you have an extra, and that happens sometimes. Okay, so I'm going to quit out of that after I have it typed in. And so what all does it? I changed my Cinti thing? Is it that weird?
Awkward permanent markers.
Awkward permanent markers, huh? But not with permanent markers.
But it was like before we came in, it's not weird.
It's aspen and birch, so it should smell like trees. Does it smell like trees? No? No, okay. So it wanted a scatter plot, so draw and label the x-axis. So what I'm gonna do, so to turn my stat plot on, one of the easiest ways, depending on what you already have it set at, is sometimes that y equals, and this sometimes gives you problems on your y equals menu if it's highlighted. So that's about the easiest way to turn it on if all your settings are already where you want them. To check your settings, so if I just pushed my graph right there, oh, I can kind of see 1 point, so it definitely didn't work. But it looks like at least it's a scatter plot. I'm gonna go do your other stuff, you know how to do this.
Wait, where is,
Okay.
where's the paper now on?
I went to second y equals now, and it's,
Well, I turned back on.
Yep.
Second, one equals.
yep, so then there's
It
on
says
or
it's
off.
on,
So
but I
yep,
wanted
if that's
two
good.
on.
You probably won't need 2 now.
Those are for like box thingies though, box and listed plots.
Okay, so make sure that it's on the dot one.
Enter.
Yeah, you should just be able to move it and press enter to wherever it is.
Do I want like all the little dots?
Yeah.
That's what I want?
Yep.
Okay, I want that instead.
I hope you can, you're not gonna be able to see this. If you need help, come ask me for help on it. Okay, X is L1, Y is L2, so you can change it, but it's generally just nicer if you put the X's in L1 already.
Okay, what do I do after that?
Okay, so then I'm gonna quit, and then I'm gonna go to graph, which is
want it
still
like
not
that,
gonna show
right?
up nicely. Yep,
Okay, cool. Secondary.
so
Good.
still not showing up nicely, so I'm gonna do my zoom, and then I'm gonna go down to zoom stat on my zoom menu, which is 9 on mine. Okay, hey, look at that, it already has it nice. If it's not exactly how you want it, so make sure you're paying attention to your scales. So if I do my trace, it will tell me what each of my little dots are. I guess you have to use up and down to move around, I don't know. Or left and right, you move left and right. But it moves them, I guess, in the order that you typed them in, not in any other order. So now you're deciding, so the next little step, whoops, I clicked the wrong thing. I don't know where I'm clicking. I don't really want this to disappear. Okay, so now the next thing, so draw and label those x-axes, so cool, ours looks about like that. Positive relationship, why did it? I guess that was it. It just wanted the graph of it. Okay.
Cool.
So then what else is your stuff doing? What else are your, let me make sure what the questions are asking you.
Just doing scatter plots right now.
Which of the variables is independent and dependent?
We're starting at the beginning.
That's, yeah. No, those are the, okay, got it. What is meant by the statement? What else does it ask you to? Based on this data, how can it be concluded that the relationship is between these things? Okay, so there is more stuff to do. We're not gonna do 10-2 because it is also pretty close to the same, or just 10-2, let me see how much that makes you do. 10-2 only asks you to plot them, so I'm gonna skip along to number 3.
What do we do for 3?
So 3 asks you for, let me read it in here. A researcher wishes to see if there's a relationship between ages and net worth of wealthiest people in America. The data for a specific year are shown. Okay, so when we graph that, so we're gonna go through the same steps to look at it in the calculator. What?
They give you X.
They did, yeah.
Will
So-
they always give you X and Y, or are we gonna have to figure it out a lot?
Generally, they have like rows instead of columns, and it looks like some of them have X's on the top, some of them have Y's on the bottom, and they're probably in the right order where they need to be already. it doesn't seem like they do much else. Okay, so we're going to draw and label the x-axes, plot each point on the graph. So we're doing this in the calculator, right? You already have done this. Let me click through this one.
We did that. Look at us go.
Yeah, that's about how. I might have to type all this one in.
Do we need to do like sketches for these on our?
Yeah, because that's some of them, that is your answer. So let's type that into the calculator. And, nope, I want to go back one. And play with these points and type those guys in. So let me grab my calculator, dude. Where are you? Okay, so I'm going back to my list. So,
All this stuff is really easy.
okay, so make sure you push clear when you're on it to come back down, and then go up to L1, clear it out, push down, don't push delete. We don't want to delete the list. It makes a pain in the butt for all the calculations that depend on it. 6, 5, 53, 54. I won't see them in case you're not on the same ones I'm on. 61, 65. Seems like they're all really old people, so. My mom told me the other day that Warren Buffett did not have even like 1% of the wealth that he had when he turned 50.
Who's that?
One of the richest people in the world.
Oh,
And he's old, but he was not old. Like, I guess he was kind of old then too. When he started getting rich, he was pretty old already. Oh, crap. Okay. So now I have to figure out which one I missed. You guys know which one I missed? 65, 61. So this has to be 65. Up here is 61. So this is a good lesson on how you change all your stuff. 69, I had that one. 79, I had that one. 54. What did I miss? Did I accidentally do another one? Oh my God, I had it all. Okay, so do I have an extra one in there? 50, 21.5, 40, I have 2 16s. Okay, now I can delete these things and that works fine. You just don't want to delete the actual list. Okay, so now I have the same numbers. So now I need to look at that graph. So I want to do my zoom stat. All my other settings should be the same. Okay, so I have this nice graph that looks a lot like theirs, yay. Very weak relationship, so it told you a weak relationship because it's not, you can't really put, you could put like one line through these guys, but to get like all of them, if you thought about like how big those squares would have had to been, like yesterday that we kind of did, this would have to be a very large square. On what? Yeah, on your calculator? Yep.
Yeah. So I entered all that stuff.
Okay.
Now what do I do?
Then you could do zoom stat. No, zoom, and then go down to zoom stat. And then it should, oh, you have a box plot, so go back to your stat plot, so y, or second y equals. Turn 2 off. Yep. And then go back, go up, oh, okay, go back to second stat plot. And then enter on that one. Press that one on, and
On. What the heck?
yeah, that is weird. Now do zoom stat again.
There.
Okay, there,
Sweet.
yep.
I had my plot 1 and plot 2 on, and I was like, I don't know what to do now.
Yeah, and your calculator doesn't know where to try to zoom in on when you do that either. Okay, so then we're going to do the correlation coefficient. I think we've actually already done the correlation coefficient. We just haven't done the hypothesis testing on it. So we're not going to go through, like, there's a formula in your book. it's crazy. It's like one of those sums of the x's and y's, and okay, it kind of goes over. There's different ways, or there's different calculations for it. So we'll just use whatever it is that, I don't know exactly what it is the calculator actually uses, so I want to look that up too. So remember how I named that row, even though it doesn't look like an R, it's basically a little r in Greek. So your calculator is going to give you an actual R, not a row.
America.
Okay, America. Okay, so population is the Greek thing, which is a row. Okay, it can only go from -1 to 1. So, strong positive linear will be close to 1. Strong negative will be close to -1. Okay, if it's kind of in between 0, and there's different, so this looks like it could be like -7. If you get like anything with the 0.9, like when you're doing real data, that's like a really awesome relationship. Or -0.9 would be as well, that would tell you something. Kind of in between 0.5 and -0.5, there's not really much of anything going on. Okay, and we also end up with sometimes looking at different correlations between different groups. So you might have like a whole population group of things that might look like craziness, like all over the place. But then like if you were to actually look at them, a lot of what happens sometimes, maybe if you isolated a group, this would be like your male group that might have a correlation. And this would be like your female group that would have a different correlation. Okay, so sometimes we'll have to isolate different groups, which I think is that maybe that's multiple regression, I think that's what it was trying to do. But we won't do much of that. Okay, so correlation is pretty straightforward. So this is a pretty weak positive linear. This is pretty good positive linear. This is like this would be like a perfect one because I can actually draw a line that goes through all of them. That very rarely happens. So if I can touch all of the points with a single straight line, that's like a 1. Okay, single, yep. Okay, this would be close to -1. This would be close to +1. These would be somewhere in between, but positive and negative. Okay, so they say 0.5, 0.9, 1. -0.5, -0.9, -1. Okay, this is the gross formula for R.
Do we need that?
No, we're going to use our calculator.
Okay.
Okay, we really
Can I write
are.
it down for note purposes?
It's in your book.
Okay.
Yeah. It's gross, so yeah, we're not. Okay, rounding rule, round to 3 decimal places, remember that. So R to 3 decimal places.
Oh, that's cool.
Okay, 10-4, we're gonna do more stuff for it. My nose is not good. And it just has you doing the R. So instead of doing that, let's actually just do the R for our last set of data instead of this example. So you have all your stuff typed in your calculator. So let me find my calculator again. Okay, so now to find my R. Okay, so to find my R, I'm using this data, but I'm gonna tell it to do stat. Am I calculating stuff? Yep, I'm calculating. I can do the linear regression.
So wait, I go to stat and do linear.
Mine only gave me A and B, which is not what I want. I want yours to give you an R. So if yours does not give you an R, what you'll need to do is go to catalog, which is second 0. And give me a second to find it on this one where I can read it a little bit better. Yep, there it is. Okay, so go down to your D's, and we want our diagnostic on. So D, diagnostic on, you're just gonna press enter again. Now we're gonna go back to stat.
So wait,
Yep. So second 0,
yeah,
and then that gives you your catalog. Everything's alphabetical. Go down to diagnostic on. And then I should be able to do that linear regression thing again. And it will work nicely, hopefully this time. Please work nice. Yeah, it'll work nice.
okay, so it's done.
Okay, and now go back to do the linear regression. Okay, so my R squared, so,
Yeah.
yep. The R is generally what we think of, but the R squared is always gonna be pretty close to it, and especially when it gets to be a strong relationship, when you think about what's 1 squared, hey, that's also 1. So if my R was pretty good, my R squared will also be pretty close. Whereas this R is negative 0.176, so going out to 3 decimal places. My R squared is 0.031. The reason why the R squared is useful is because there's different, so that big gross formula that we looked at, that is only for that linear piece, whereas there's different formulas for the quadratics or the other pieces that we're gonna use. Okay? So, is that a very strong relationship? Negative 0.1676. Okay, so not very strong. So there's not much correlation between the age and the wealth of those particular people that we looked at. Okay, so to find your regression, so now, did you find it? We're gonna skip that guy because we're not gonna go through all of that work. Okay, because then you'd have to find the sums. Remember doing all this at the beginning of the year? Kind of, and it was really gross. Yeah. See, we've already done all of it.
So we're not doing any more, right?
We're going to do, does 10.5 make you ask more things? Okay, so I want 10.6. I'm gonna skip to 10.6 too, because we're gonna skip that gross stuff. Well, you're not gonna skip it, you're just gonna have to do it. It's gonna take like 10 seconds to do it instead of whatever this is. Okay, so hypothesis testing for this stuff. So you're gonna say my null hypothesis, H0 rho equals 0. That would mean that there's no correlation between this. Where is this thingy at? In here, so I can read it better. I'm not skipped forward yet. Let me skip forward on this one. Okay, so our null hypothesis is that rho, our population correlation coefficient, is 0. That would mean that there's not. The alternative hypothesis would be that there is a significant correlation between the variables in the population. Okay, so we're going to have a t-test for the correlation coefficient. So we'll have to use r and r squared for this thingy, which your calculator is going to give you. Okay, the degrees of freedom is going to be a little bit different. So remember, we're using that t-chart anytime you have a t-score. So make sure you have that guy written down. I'm going to write it down so I can use it off the same. Okay, so I'll have n minus 2 over 1 minus r squared. Okay, degrees of freedom is n minus 2. So that's going to be the only kind of weird thing that you're going to do. That's going to change a little bit anyway. Okay, so you're stating the hypothesis.
Hey, but it's not bad since we can find, like, we get our R and R squared.
Yeah. Yeah, that would, this would be disgusting if you had to use all of those hand equations. Okay, so test the significance of the correlation coefficient found in example 10.4. So example 10.4, which one was that? We skipped 10.4. Okay, so let's read 10.4 to you. It was compute the correlation coefficient for the car rental company. Of course, that's not the same one I have anymore. 10.8 was about 10.6, and we did age and wealth. Okay, I'm going to skip one more time so that we already have the data typed into our calculator. And then it's not crazy to think about. Okay, so this was the age and wealth thing. So using table I don't know if it's an I or a 1. Test the significance at a 1% level. That's an alpha equals 1% of the correlation coefficient. R equals negative 1.6. Again, this is just weird. Rho, and our alternative hypothesis is that rho is not equal to 0. So 0 meaning that there would be no correlation for all of that data that we already had. And I erased my R and R squared, but hopefully it's still up there. Okay, so there's 6 degrees of freedom. So, because I had 8 things that I typed into my calculator. So you just ask yourself how many pairs of data did I type in, and then my degrees of freedom is 2 from that. So, where's my nice chart? Okay, so I have my T chart. Maybe I have my T chart. Degrees of freedom is 6. So, and then just make sure you can find that alpha 0.01 for 2 tails. That is just because there will always be 2 tails on these things because it's always not equals 2, so it's kind of for these guys, yep. So 6, they have point. Table in I. This is not table I. Do they have a different table for this? So this should be on page 793 in your book, so you'll have to find 793. Not, I guess, the same T-chart we were using before. Okay, so no, it's totally a new table, but it is easier to use. Okay? So you only have 2 columns, so we'll either have a 5% critical value or a 1% critical value. Okay? It's all for the nice, everything's already set up for you. So you have n minus 2, so 6, so 0.834. Okay, so make sure, so 793. Don't forget that.
Wait, why? Oh,
That is the table we're going to use. Okay? On that table, you find this thingy. You should be able to find that guy. So, using that table then, so our significant relationship R must be greater than the 834 or less than negative 0.834.
So it doesn't because it's not greater than? Okay.
Yeah, so we do not reject the null hypothesis because of that. So that's what some of your stuff will look like. We should have already found, so maybe that is for a different method. I think that's for like, remember how we had like the 2 methods, the p-value method and the,
Yes.
I think that's what that's for. Okay, so
Hey, this makes a lot more sense than the
easier graphs. You don't have to do like the curvy graphs. So no curvy graphs. This is a graph.
About the curve.
Yeah.
Yeah, for some reason, this still just makes a lot more sense to me.
Should be enough. Okay, there's not enough evidence to say that there is a significant linear relationship. That doesn't mean there's not a relationship. That just means it might not be a linear relationship. Sorry, I'll go back. That's what your graph should look like. Let me click through so you can look at your, is that it? 834, 176, okay. So that's what your graph should look like. Okay, when the null hypothesis has been rejected for a specific value, any of the 5 possibilities can exist. There is a direct cause and effect relationship between it, that is X causes Y. There is a reverse, Y causes X, that would make Y the independent variable. The relationship may be caused by a third variable, so we kind of said time and temperature and maybe the pressure, those could be the 3 relationships there. Okay, there may be a complexity of interrelationships between variables, which should be like the multiple regression piece of it. Is that it? I think that's it. Nope, there's more. Just kidding. There's always more. Relationship may be just a coincidence. Like one of them I always can remember doing this was that since whenever, 19, whatever, pick a random year, There's been more fluorescent lights in school. The number of fights have also risen in school. Did the lights cause the fights? No. So that's just a coincidence. Okay, direct cause and effect. Water causes plants to grow. Poison causes death. Heat causes ice to melt. Those are direct cause and effects. Okay, those are not hard. Those are usually things that we kind of think about. Okay, reverse cause and effects. This is, oh my gosh, this is ridiculous. That's a long one. Suppose a researcher believes excess coffee consumption causes nervousness, but the researcher fails to consider that the reverse situation may occur. That is, maybe an extremely nervous person craves coffee to calm his or her nerves.
Wow.
So that's just a really long, terrible example. Third variable, if a statistician correlated the number of deaths due to a drowning and the number of cans of soft drinks consumed daily during the summer, he or she would probably find a significant relationship. However, the soft drink did not cause the deaths since both variables are related to heat and humidity. Okay, complexity things. Researcher may find a significant relationship between high school grades and college grades, but there is probably many other variables involved, such as IQ, hours of study, influence of parents, motivation, age, instructors. Coincidental, I already gave you a coincidental one. Okay, lights and fights. Okay, so it should not be awful. It should be hopefully easier than what the last few pieces were. Chapters. Maybe a